So this is LeetCode problem number 18, and the problem is nothing but 4 sum. Okay, and you can see this is nothing but the variant of the 3 sum problem. Okay, so we are given an array of numbers, or you can say nums of n integers, and we just need to return an array of all unique quadrats. Basically we just need to return 4 elements from the array. You can say this is nums of a, nums of b, nums of c, and nums of d. Okay, such that this 3 belongs to this array, or we can say in between the array index, that is nothing but in between 0 and the last index of the array. And we need to find this element such that, okay, this, you can say this a, b, and c both are distinct. Okay, a, b, c, and d, 4 are distinct. Okay, and basically we just need to form target with the help of this 4 element, okay, from the array. And yeah, we can return this in any order. Okay, so you can also see this example also. So basically what I need to do, will be given an array, you can see, and you're also given a target. So what I need to do, we need to find 4 elements from the array such that, okay, we can achieve a sum that will be exactly equal to the target. Okay, and we just need to return the answer such that all the elements, or you can say all the all the 4 elements are unique. So you can say for this array, this is the target, so we just need to find 4 elements such that we can achieve a sum of 0. So you can see this, uh, these 4 elements will give us 0 as a target. This will also give us 0 as a target. This will also give us 0 as a target. But this 3, okay, these 3 answers are different, or we can say unique. Okay, so basically we need to return this kind of unique solution for every test cases. Okay, okay, so as I said that this is nothing but a very similar problem to the 3 sum problem. So just let me help you to recall the 3 sum problem quickly. Okay, example, and as you already said that this is very similar to the 3 sum problem. So we'll do exactly the same that we already did for solving the 3 sum problem. Okay, and if you want to recall what we did in the 3 sum problem, then what we did, you can say that this array is not sorted. Okay, so first of all what we did, first of all we sort the array, we sort the given array. So you can say first of all we sort the given array. Okay, then what we did, then we simply use a loop. Okay, then we simply use a loop to iterate through the sorted array. Okay, and then again, okay, in between this loop, okay, we use two pointer approach. Simply we use two pointer approach, you can say two pointer approach, to find the raised to element, because with the help of this loop we will able to find a single element. Okay, and using this two pointer approach we'll able to find the raised to elements. Okay, this is the thing we did in the last problem, or you can say we did in the 3 sum problem. Okay, and the thing is, if you are not able to understand this kind of things, that means you haven't checked out the 3 sum problem. So just I provide the link in the description, please go and check the 3 sum problem. Okay, because that is the prerequisite to understand this 4 sum problem. Okay, now as we already said that the code will be exactly equal, but the thing is, in 3 sum problem we only need to find 3 elements from the given array. Okay, but you can see this is the 4 sum problem, so basically we need to find 4 elements from the given array. So basically we need to do the same thing, but we just need to add something, and this something will be nothing but, just let me erase this part. Okay, and we just need to add another loop. Okay, we just need to use another loop here. Okay, so you can see within this loop we just need to use another loop. Okay, so we just need to use another loop, then in this loop, or we can say then in nested loop, we just need to apply, we just need to apply the two pointer approach. Okay, here we need to apply the two pointer approach for this problem. Okay, so if we summarize the approach, then what we need to do, first of all you can say this is the unsorted array. Okay, so first of all we need to sort the array. Okay, then simply we need to use a loop to iterate through, then again we need to use another loop in between that loop, okay, to iterate. So basically using this inner loop we'll able to find a single element, or you can say, and using this nested loop or inner loop we'll able to find the second element. Okay, and the rest of the two element will able to find using this two pointer approach. Okay, so we'll be using this two pointer approach to find the raised to element. Okay, and that will be the very simple approach, okay, that is already discussed in the three sum problem. Okay, so please check out that problem before start this problem. Okay, and yeah, now we simply jump towards, now we simply jump to the code section so that we can code this approach, because this will be very similar. I'm not going to explain the everything because I already did in the three sum problem. Okay, now let me code the approach. So first of all, as we said, we need to sort the array, right? We'll be basically will be using the inbuilt sort function. So the approach is nothing but we just need to sort, so we'll be using inbuilt method. So arrays dot sort, and we just need to pass the array that will be nothing but nums. So that is sorted. Now what we need to do, we need to simply we need to iterate through the array, right? So we'll be using a loop to iterate through, and let's say the loop will start from 0 and it will goes up to length minus 3. Okay, just let me do this first. Nums dot length minus 3. Okay, and it will increase every time. Okay, now you can ask me why this is a length minus 3. So you can say that you already know that we need to find four elements, right? So this will be the outermost element, and using this loop we just need to find the one single element, and apart from this we also need to find three more elements. Okay, that's why this loop can go at max length minus 3 position. That's why we are using this. Okay, and again we said that we need to use another loop, right? That will be our inner loop. Let's say here I will start they will start from I plus 1 position, and every time they will they will go till nums dot length minus 2. Okay, because we already get two elements and we also need to find two more elements, that's why it can go up to length minus 2. Okay, and every time j will also increase by 1. So that is, and we said that we need to use two pointer approach in between this inner loop. So we'll be using two pointer approach. Let's say our first pointer name will be, let's say, left one, and we already know that it will start from say plus 1 position. Okay, let me assign this value. So it will start from say plus 1 position, and our second pointer, let's say, name will be right. Okay, and it will start from the last position of the array or last index of the array. So this will be nums dot length minus 1. Okay, now we need to simply apply the two pointer approach. Basically we discuss everything in the three sum problem. Okay, please watch or please check out the three sum problem before starting this problem. This is highly recommended. Okay, so we just need to use the condition, and that condition will be nothing but until till left is less than right pointer. So this loop will continue, and every time we just need to find the sum. Okay, sum of the four elements. So you can see with the help of I pointer, this outer loop iterator will be able to find a single element, and using this inner loop pointer, that will be nothing but z, will able to find another element, and rest of the two element will find using this left and right pointer. Okay, so the sum will be nothing but, let's say, sum is nothing but what, sum of this four pointer, that is nothing but nums of I plus nums of j plus sorry, my bad, nums of left pointer and nums of right pointer. Okay, this is nothing but the sum. Now we just need to check, okay, whether this sum is exactly equal to the target or not. So we just need to check if this sum is equals to target or not. Okay, if this equals, then what I need to do, if the target, if the sum, that means sum of this four element is equal to the target, then what I need to do, we need to store that sum, right? We need to store that sum. We need to store four elements into our resultant. Okay, but before that, you can see we just need to return a list of integers. So let me first assign this list of integer. Okay, let me initialize our resultant list of integer. So this will be list of integer. Let's say the name is nothing but results. Okay, so we'll be taking an array list. Okay, so that's it. Now let me store this value into the this list of integer. Okay, but you can say this list of integer basically accept a list of integers. So first of all we need to initialize the list of integers. So let me initialize first. So it will be list of integer, and let's say the name is nothing but temporary temp equals new array list. Okay, now let me add the this 4 value into this list. So our temp dot add what temp. First of all we need to add the I pointer. Okay, so nums of I. Second, we just need to do the same thing. Let me copy the thing. Okay, so copy and paste it over. Okay, now we'll basically add the second pointer, that will be nothing but say. Then we'll add our left pointer value. Then we again need to add the right pointer value, right? So right pointer value. Okay, so we added the 4 value into this temporary list of integer. Now we just need to input need to add this temporary list into this resultant list. Okay, into this result. Okay, so what I need to do, we need to simply add this. So you can say result dot add this temp. Okay, this is very simple, but you can see that I'm using this kind of a lengthy lines of code to do this, but there is a convenient approach that is already told in the three sum problem. So we'll be using a single line statement. Okay, we are not gonna go with this approach. So what we'll be doing in this step is that will be very simple. Okay, so what I need to do, we need to simply use a inbuilt method. Okay, that belongs to java.util class. So basically we need to use that. So the method name is nothing but arrays dot as list. Okay, so basically this method return a list. Okay, directly, and it approximately take constant time. Okay, to do that. So basically in between this function we need to pass the values, or pass the element we need to store in the list. So that will be nothing but our 4 elements. So nums of I. Okay, nums of j, then nums of left pointer, then again nums of right pointer. Okay, so you can say this is very simple and very convenient approach to do. Okay, let me wrap this. Okay, so yeah, now we just need to simply add this. So you can see this, I already did this. So you can see right now this is very convenient, and this is one line statement. So yeah, I'm just comfortable to go with this approach, but you can go with the approach that that I saw earlier. Okay, okay, now what we need to do, we already check this condition. If the sum is equal to the target, then we need to do this, we need to store this value. Okay, and there could be other condition also, we just need to check. Okay, else if what could be the condition, else if our our sum value of the sum can be greater than the target, right? Okay, can be greater than target. Then what I need to do, if the sum is greater than target, then what I need to do, we need to reduce the value of sum so that we can approach towards the target value, right? And think like, if we want to reduce the sum, what I need to do, we need to simply reduce the right pointer by 1, because the array is sorted from left to right. And if we simply reduce the right pointer by one place, then our value is also, our the value of sum will reduce, right? So we simply need to reduce the right pointer by one place. Okay, And again there could be only one possible case, that would be nothing but in this case, okay, in this case our sum will be nothing but less than the target, okay. And if the sum is nothing but less than target, then we simply need to increase the value. That's why you simply, you can say we just need to increase the left pointer by 1 plus, okay. And this is a very simple approach. So we did everything, and last of all, when we'll be out of this loops, then we just need to simply return the results, okay. So this is the whole code, but this is not the everything we need to do, because if you notice the question carefully, we need to, we need to return the results, we need to return all unique results, right? So if you simply do this, it will, this list of integer will store all the duplicate results also, okay. So to ignore the, duplicates one, we already explored everything in the three sum video, okay. Now let me do this simply. Okay, just we need to use some conditions so that we can overcome the duplicates, okay. So basically, for this loop, for this outermost loop, our condition will be, if I is greater than 0, okay. And the current, if the current value is exactly equal to the previous value, then we need to, simply skip every process, okay. Then we need to simply skip everything, okay. And the condition will be nothing but if this nums of current value, means nums of I, if this is the current value, if this is exactly equal to the previous value, okay, nums of I minus 1, that you already explored, okay, then we simply need to skip everything. So we need to use simply continue, okay, as simple as that. Again basically we need to do the same thing, okay, we need to do the same thing with this inner loop also, okay. So here the condition will be nothing but, if our z pointer value, if the z pointer is greater than I plus 1, then we need to check whether the current value of j is exactly equal to the, previous value of the j pointer. Then we need to simply, skip everything, because you already did same thing in the, previous iteration, right? That's why. And we again need to do the same thing for this also, okay. So okay, here we miss something. If we encounter with this, then we need to, here we need to, increase the left pointer by 1 plus, and we also need to decrease the right pointer by 1 plus, okay. Now just let me do the condition so that we can overcome the duplicate. So what will the condition, okay, the condition will be nothing but while, this left less than right, okay. And if this is the condition, and the value of the left pointer is exactly equal to the previous point, previous value. So the thing is, if nums of current value of the left pointer, this is left, is exactly equal to the previous left pointer value, that is left minus 1, okay, then we need to do the same thing. That means we need to increase the left pointer again, okay. And we do the same thing with the right pointer also to overcome the duplicates, okay. So let me do this over here also. The condition will be same, but it will be right. And if this, the, current value of the right pointer is exactly equal to the previous value of the right pointer, that is right minus 1, previous value is nothing but right plus 1, okay, then what I need to do, we need to simply reduce the right pointer by 1, okay. So right pointer by 1, okay, that is the thing. And yeah, again we explain everything in the three sum problem. Please check out this, check out that video before, okay. So that is the thing. So now you can say this is the whole code, okay, and this is very simple. So what I did, let me explain again. So first of all, we sort this, you can see, first of all we sort this, then we use for loop to iterate through the sorted array, okay. And this will be the outer loop that will give a single element, okay, for the result. And we are using this condition just to overcome the duplicates answer, okay. So again we are using another loop, okay, this is the inner loop, you can say. just to find the next element, or you can say the second element. And in between this inner loop we are using the two pointer approach. You can say this is the two pointer approach. Okay, this is the two pointer approach. So just let me comment out over here. Okay. So this is two pointer, this is two pointer. Okay, and this is outer loop. Okay, and this is nothing but inner loop. This is inner loop. Okay, and yeah, this is outer loop, this is inner loop, and in between this inner loop we are using this two pointer approach, and this is very simple. Okay, and now let me just run this code to check whether we have some error or not. Okay, so you can see all the test cases are working very well. Now let me submit this code, but before submitting this code, just let me confess a thing. Like, if we simply submit this code, this submitting this code, just let me confess a thing. Like, if we simply submit this code, this will get some error, but I want to show you the error that will be getting if we simply submit this code. So you can see this is not submitted yet, so you can see I got an error for this test case. Okay, so just let me big the screen. Okay, so this is the input. Okay, for what I got some error, but you can see this is the input. Like, we have four elements. You can see we have four elements, and the length of the input array elements is nothing but same as 10 to the power 9. Okay, so just let me first, if you notice carefully the problem statement, then you can see that there is some constraint. Okay, so you can see the nums of I, the elements of the array can go up to 10 to the power 9. Okay, if it reaches up to 10 to the power 9, then it will simply go to the direction of integer overflow, right? So the thing is, this is the four element. So basically when we are adding this four elements, so this is the sum. Okay, so we are using integer type, okay, to store this four element, to sum this four element. Okay, so basically when this four element gets summation, then basically it will overflow from integer type. That's why we are getting this kind of wrong this kind of wrong result. So what we need to do, we need to simply do this. We need to simply use the long type. Okay, we just need to simply do this. And again, okay, if you simply take this long type and do the same thing, okay, this will again give you some error. Okay, just let me show it again. Okay, if we submit this, okay, it will again give you the wrong wrong result for this. So what happens with this code? Okay, just let me explain this. Okay, so basically nums of I, this value is nothing but integer type. Okay, so this value is integer type, this value is also integer type. So you can say this four value is nothing but integer type. Okay, so first of all this four value, you know uh, first of all this four value added. Okay, and then basically you can say it overflow the integer type value. Okay, that's why we are getting the overflow value that is stored in the long type sum. Okay, what I need to do, we need to simply split these numbers. So we just need to sum plus equals to this. We just need to simply split these numbers. Okay, then sum plus equals this, and again for this. Okay, so we just need to simply split this, because now you can see this is integer type, but it gets stored in the long type. Okay, so right now you can say this sum is nothing but a long type. So if this is integer type, but it's get addition to the long type. So in this process the value does not overflow. Okay, so that's why you get the correct answer. So let me submit this code, so you'll have to see how it gets submitted. Okay, you can see now it gets submitted. Okay, so this is the everything. Okay, but yeah, I just need to explain the time complexity. So you can see that. Okay, so I'm using this is the outer loop. Okay, first of all I'm using sort, so this will take nothing but n log n time complexity. And this is the outer loop, this will take n log n, this will take log n time, sorry, big of n time, this will also take big of n time. Okay, and we're using this two point approach, this will also take big of n. So overall you can say this is big of n, this is big of n, and this is big of n. So nothing but big of n cube will be the time complexity. And if we talk about the space complexity, then yeah, we are using this list of list, okay, just to return according to the question. But if we just ignore this, then we simply using we are doing the sort only. So the sort process roughly take big of n space just to sort the element. So we can see we are using only big of n elements. Okay, big of n space if we simply ignore this output array, output list of integer. Yeah, and that's it.